All right, let's begin with the first part. This homework, as even though it looked like it was difficult, it actually wasn't. You just had to read it and understand what they were asking you to do. So let's get this guy on the other side and solve it. So this one says, actually, I'm going to have Jennifer to tell me what to do here. Yes. Okay, good. So I'm going to write the coordinates first. And I'm going to do it the way that I showed you because I believe that makes more sense. However, you can do it any other way you want. Um, and the formula, which we actually call the rule, right? This is the rule. It's written that way, and I showed it to you a little bit differently. Yes, it says take 6 away from x, right? And take 3 away from y. The what? Yes, it should switch papers. And this gives you the new value. So we're going to do the same thing for all of them. So now all you have to do is solve vertically, right? 0 minus 6 is negative 6. That's your new coordinate. And that will give you negative 5. Negative 6. And then 3 minus 3, 0. And then right here is negative 3. And then this negative 5. And this is 0 and 0. Did I write this right? No, this is wrong. It's supposed to be 6. So negative 3 and 0. Negative 3 and 0. And these are your new coordinates. And I wanted you to do it this way because you're literally saying I'm taking away, I'm adding, or whatever to the x and the y axis. Now, when they ask you describe a translation, they just want to know what is happening. So what happened? Exactly. 6 units to the left and then 3 down, right? That's it. That's all I needed. You said you didn't get it. Yeah. Hey. Yeah. Will you get it now? Good. You do. Or you add, depending on what it says. Careful. This one is slightly different. We're talking about a reflection. They give you a rule. No, you're supposed to figure out the rule. Yes. Yes. This is A. B is 0, 5. And C is 3 and negative 1. So what do I do again? Does anybody have a different option? Yes. Exactly. So you're reflecting across the x. So notice how I saved the x over there. That means I have to save this one too. And which one is it changing? The y. So for all of them, it'll be the same idea. The x does not change, the y does. And I'm doing it that way because it's easier to understand. But what does the rule say to do? Yes, you multiply the y coordinate. You leave the x alone, but you multiply the y coordinate by negative 1. So you put negative 1 times the y. And that's it. So, which is the same thing, right? But I think our method works a lot better because you don't have to think about it. You just know. So we're going to keep, for A prime, we're going to keep -2. We save it. And then we change the sign of the Y. B prime the same way, keep 0, and this becomes negative. And then C prime, 3, and then it becomes positive. There we go. The ones in red are the originals, the pre-image, and then the ones in green are the image. They're the primes. Yes. No, when do you flip these? When you're rotating. This is not rotation. What is it? You do not flip it unless you're rotating. All right, moving on. Oh, wait, do we have any questions on this? How many of you got it right? Yikes. Okay, half of you. How many of you got the first one right? Okay. For the other half, I need you guys to go back to the video and watch it. Or ask me right now so I can clarify. It seems like you're freaked when I ask you. Okay. Here's the thing, guys. Whenever you're doing reflections numerically, algebraically, you do not graph it at all. You just do it numerically like we did. That's the whole thing. Did I graph anything? No. That means you save the letter, go back to the video and watch it, okay? I already posted it yesterday, and I'm posting it this one today, Smarty Pants. It was at 9. It was late at 9. No, you didn't. I was trying to catch you on your lie, and I caught you. Yep. All right, so let's take this one over there. This guy, how are you going to tell me it's a big lie? Which one? This one's better. I think this is, because it's darker. It's darker, and it's, well, the other one, it would have like lines in the middle, and it couldn't keep going. Yeah, and this one is just, it goes by page. All right, so this one isn't that much difficult. It says write an algebraic rule to describe a transformation. In other words, what's happening? So what is happening for this one right here? Do what? That's a transformation. That's what you're describing. 3 to the left. Is that it? 2 to the left. To the left. And how many down? 5. Look, all the way down here. 5 down. All right, so that's not a rule. Well, how do you write the rule? It was like the very first problem. So x minus 2 and y minus what? That's it. That's all I need. No variations of that. That is exactly what I needed. And I need you to get used to that. That was the rule. That was part of yesterday's lesson. And that was also on your notes. So that's all I needed. Nothing different than that. For the next one, what was the transformation? Rotation. And you can just say 180 degrees. It doesn't matter which direction. You can land in the same spot. But I needed to know there was a rotation from 180. What about the algebraic expression. Uh-huh. What happens to it? Thank you. That's what I needed to hear. Multiply both coordinates by -1. That's it. This is it. This is exactly what I wanted. You get the coordinates of the image, multiply them both by -1, and you get the rotation points. They don't flip either. Seems like somebody uses the notes and the rest of you wait on something else. Because the rule says that. Go back to your notes and check the third one and read it to me out loud. Hang on, she's reading something. The third one about 180. Loud, loud, so everybody, the whole class can hear you. Does it say to flip anything? It does? There you go. This is what you read. Yes. You can, guys, these books are consumable, meaning you can use them, you can take them. It is up to you to take these things home and keep them if you want them. They're yours. I don't want this book back after you used it. I don't have the stuff that I need. So if you take notes on them, take it home. That's, oh, Jesus. I think you need too much, though. All right. Well, here's the thing. Crazy people are defined as people who continue to do the same thing over and over again, expecting a different result. That's crazy people, yes. So, if you continue to do the same patterns every single time and you expect to get a different grade, you are, by definition, crazy. So, so I need you to notice that your patterns are not working so you can change them. Yes. On which test? Yikes. Good. Congrats. All right, for this one, triangle XYZ has vertices X, Y, and Z. Bigger story. When translated, X prime coordinates are that. Write a rule to describe transformation, then find the coordinates of X and Y prime. Did anybody successfully get this one right? What did you get? What is the rule? Yes. Yes. Okay. So we get X, which is 6 and -2.3. We have Y, which is 7.5 and 5. We have Z, which is 8 and 4, right? And then something happens, and then you end up with 2.8. And then, hang on. You end up with that, right? Those are the new coordinates, X prime. They're asking you what happened in the middle, which is the rule, right? What do you have to do to get 2.8? Subtract 3.2, right? And to get this one, you add 1. It's negative. If you added a -1, you would have ended up with -3. I mean, if you had -1, it would be -3. Negatives and negatives add up, right? So this is a rule, right? Subtract 3.7 from the X, add 1 to the Y. Yeah, 3.2. So you do the same thing to all of these. And now you just find the new ones. So this one gives me 3, 4, negative 4.3, this is 6. And then I get here 8.5. No, 4.5. Is that right? 4.8, sorry, what am I saying? It's right there. And then 5. There you go. So those are my new coordinates. This is going to be y. It's not negative, so you're right. What am I saying? Okay, so those are the new coordinates, and we know that the rule is this one. So when they ask you to say to explain your answer, or wait, to describe transformation, what happened? Like the other one, what happened to the shape? Yes, it moved 3.2 to the left and then 1 up, right? That's it. It's very simple. They just want you to know, they just want you to tell them what happened. What did you do here? All right, the next one. Point L has coordinates 3 and negative 5. The coordinates of point L after a reflection are the following. So that one's really easy too. If point L is 3 and negative 5, not prime, and now point L is negative 3 and 5 for L prime, what happened in the middle? This is a reflection, by the way. So the x changed and we kept the y, right? So what does that mean? What do we reflect across? We reflected across the y-axis, right? That is it. That's all you needed to know. And the rule will be to do what? What is the rule? Yeah, multiply x squared by negative 1, and the y stays the same. I know this is a lot, but you need to go back to your notes on the rules. The rules are not difficult. They're very easy, but you have to look back. You will not remember these things if you look at them once and they're like, oh, I got it. You don't. Please go back to them. All right. And the last part. No. I never said that. But if you did, congratulations. It looks like he shrank the wrong way. Whatever. All right. So for this one, use the rule x, y, z. Wait, no. X, y, x minus 2, y minus 4 to grab the image below. Of the rectangle, then this is the transformation. So I'm going to use the easy way. Go 2 to the left and 4 down, right? So 2 and 4. That's C prime. 2 and 4. That's B prime. 2 and 4. That's A prime. And then D and 4. That's D prime. And we're done. What happened? It's a translation, and what happened? 2 to the left and 4 down, right? That's it. The next one, parallelogram, ABC has vertices, that, and that. So we're doing this one not by graphing, but algebraically. It looks crazy, but I promise you it's not. So let's put these things right here. And we're talking about translation, so we're going to do it this way. 5.5, and then B is negative 4 and negative 5.5, and then C is negative 3 and negative 2, and then D is negative 1 and negative 2. All right, so it says that the translation of 4 units down. Are we doing anything to the x? So we'll leave it alone. But we know we have to subtract, right, because we're going down 2.5 from each of these. And what is our answer? That's right. Why is it that we don't get 3? They're both negatives, right? It's boys, girls. There's just a bunch of boys. No, they don't. They don't. Are we multiplying or dividing? No. The only time that the negative turns to negative equals to positive is when we multiply or divide. This is last semester stuff. Are we adding or subtracting? Yes, we are. We're subtracting, right? Therefore, we use the boy-girl situation. 5.5 boys and 2.5 boys, we end up with 8 boys, right? For the I don't know what number that is, but for that time, use boys and girls when you're adding and subtracting. Use the rules of multiplication and division when you're multiplying and dividing. Do we understand that? If you don't get the boys girls situation, then don't use that. But do not confuse the two, because this will never give you 3. It makes no sense. I'm talking about the signs. The signs are what matters. What are we doing here? Are we multiplying? What are we doing? We're subtracting. So when we're subtracting, I don't even look at that poster, because that poster says multiplying or dividing. I'm looking at, well, I have 5.5 negatives and 2.5 negatives. How many negatives do I have? 8. Please go back to the videos. I gotta keep saying that. All right, so on this one, we ended up with -4 and then 8 again, -8. And then we have 3 and we get -4.5. If you put -half or +half, that's another way that you're not getting these right. And then the same thing. These are integers, guys. This is from like last year. You should have gotten this last year. But those are our new coordinates. Another thing, if you're struggling with integers, go to IXL and practice on those. Integers. Just type in addition and subtraction with integers, and that's going to help you. That was it. So, all right, everyone listen up. I'll take a couple of minutes to explain something that I explained last semester, but I think it needs a little bit more clarification or just a refresher. If I have -2 plus 5, -2 is it a positive or negative? Negative. So we say this is a boy, right? +5 is a boy or girl? A girl. So when you combine them, who's left alone? 3 girls, right? 3 girls, because I have 5 girls and 2 boys. If I have 4 boys, right, because they're negative, -6, even though you're saying I'm subtracting +6, this is actually negative. This is still negative. The negative and the positive, and the negative and the minus are the same thing. That's what I want you to understand. The negative sign and the minus sign is the same thing. I can flip them, and I will have this. Well, I just showed you. I added 5 to -2, right? I get 3. I'm gonna use the bank account. I owe $2, right? I deposit $5. How much money do I have? 3, right? I paid off the $12 that I owed, and now I have $3 left. If I owe $4 and then I take out $6 more, how much money do I owe? $10. So boy and boy, when you combine them, you end up with 10 boys. If I have, the thing is that people, it works differently. Some people understand the boy-girl situation faster, and some people don't understand money very fast. Whatever, you can use either one. I just want you to know it. That's it. So for the money again, if I have $6, well, if I owe $6 and then I add $4, how much money do I have? No, 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 we're not taking away. Listen carefully. I owe $6 and then I deposit $4, what's my balance? I'm going to say it again. You owe $6, right? You owe $6. You have to pay that off, right? And then you deposit $4. What is your balance? Listen to the question. You're still owing $2, right? Because you haven't paid it off. If you owe $3 and then you spend, meaning that you're taking away $10, what is your balance? You owe $13 now, right? You're taking away more money, meaning that your balance is getting lower and lower. If you have $6 and then you spend $30, what's your balance? Listen carefully.
You owe 24.
You only have $6. You go to the store and you spend $30. I owe 24, right? Yes, I have $5 and then I go shopping and I spend $65. What happens? Because I only had 5, right? That means I had to borrow the other 60. And it's negative because I owe that money, right? You can, but it's going to be difficult to go on a number line from big numbers. The shorter numbers, yes. If I am at -2, and then I take away 3, which direction am I going, right or left? This way, right? So I'm going to go 1, 2, 3. I ended up at -5, right? That's it. That's a number line. But it doesn't really work well with bigger numbers. Okay, but it still is a way to show the integers. Please review this on your own, okay? Or go back to the videos on integers that we did before. It's on IXL, yes. Do not apologize. Those things need to be clarified, and I'd rather you tell me. Okay, so dilations are the next part that we're gonna do. Don't worry about it. It's not gonna be in your book. Just look over here. I mean, it's in your book, but we're not gonna cover that part. I want you to think of dilations as transformations such as reflection, translations, and rotations. Do the shapes change? They shrink. Do they expand? I'm talking about reflection, translation, and rotation. No. If it's a reflection, it's exactly the same copy, right? If it's a translation, you're just moving the same picture around. Dilation is a different story. So what is the rule for congruency? What do you need to have to be congruent? Same size, same shape, same angles, right? When you say same shape and same size, you're automatically saying it's the same measurement. So same shape, same size, and same angles, right? When you're talking about dilation, I want you to look at where the light hits my hand on this side and where the light hits my hand on this side. And as I walk forward closer to the point of where the projector is, what happens to the light on my arms? What happens? It's decreasing, right? It's getting smaller and smaller. That means the picture, which is this one right here in the back, right here is a full effect, right? It shows you everything. But as I get closer, this picture essentially shrinks up to where the point where it gets to that light. So in other words, the light is a very point of dilation, and it goes all the way over here. It projects. But in reality, do you think that this whole projection, which is a rectangle, literally shrinks all the way in there? Are you sure? Give me your book. Does it? Look at it. It does. The image. If I get farther away, it doesn't fit. But the closer I get in, it fits in this book perfectly. It might not be focused, but I still see the light of a rectangle, right? That's what a dilation is. It just basically means that you get one shape and you're making it bigger or shorter according to a scale factor. Well, the scale factor is me moving closer to that point or farther away. If I'm over here and the picture is about, let's say, this size, and I take 2 steps back, which will be my scale factor, then it gets bigger. If I take 1 more step, then it gets the biggest one it can get because of the limitations of the wall, right? So the stepping is the scale factor, and this is just the image getting bigger or smaller. Now tell me, is this image changing shape?
No.
This is changing angles. What is it changing?
5.
Simply size, right? What does it make it then? Similar. Similar. It's no longer congruent, meaning it's not exactly the same, but it is similar. So I'm going to show you another example that proves this idea or this concept. I'm going to grab this one right here, and I'm going to clone it to where it's exactly the same as that one. And watch what happens when I expand it. What happens? It just got bigger. Now, can 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 you see the angles are exactly the same? The shape is it the same? Of course, but either way, I'm going to show you that they are. Look at the angles. They match perfectly. Each one of them does. It doesn't matter how big or small the picture gets. The angles stay true to themselves. This means that the shape expands or shrinks proportionally. What does that mean, proportionally? Equally in a constant rate on all sides, right? Equally on all sides. So for example, I'm just giving you an example. Move this right here. Let's say this is 4 and this is 4. And now this is 8 and this is 8. The scale factor is whatever you multiply in the first picture to get to the second picture. So what is that? 2, right? 4 times 2 gives me 8. 4 times, what, right here? 4 times 2 gives me 8. So we say that the scale factor is 2. That's it. It's very simple. Well, yeah, that means you're not dividing, you're multiplying. All of them get multiplied by 2, but every single side gets multiplied by 2. You cannot just multiply one side and not the other. It has to be proportional. Otherwise, it's no longer similar. Now let's move. Let's switch these cases. What happens if I have these two right here, and they're opposites? Kayla, don't lose me. Well, when you have a scale factor, you don't divide by it, you multiply by it. So let's say this is 8, this is 8, this is 4, this is 4. What would I have to multiply 8 by to get me 4? That gives me negative 8. Negative 4. I'm sorry? I cannot divide it. I have to multiply. Think about it.
I think I have it.
What? 0.5. Turn it into a fraction. By half, right? If you multiply by half, I wanted you to turn it into a fraction because it makes better sense. What is 8 times 1? 8 divided by 2? 4. Listen to what I'm saying. So if this will be your scale factor is half. But if you notice, I'll show you another trick. Let's pretend that the shapes are proportional and that this one is 2 and this one is 8. What would I have to multiply this by to get me 2? 3/4? By 1/4. But watch what I do. If I multiply 2 times 4, it gives me 8, right? So you can work it backwards and say, well, I'm multiplying by 4. All you have to do is put it under 1. Whatever number you multiply by coming backwards, put it under 1, and that will give you the scale factor. That way you don't have to start figuring out, well, what can I have to multiply it by so I can get a smaller number. Every time that you go from big picture to small picture, your scale factor is less than 1. That means it's going to be a fraction or a decimal. Every time you go from a small picture to a big picture, what happens? You're increasing, right? So that means it has to be a whole number and bigger than 1. Do we have any questions on this so far? Dilations aren't difficult. And when you, yeah, because you can actually prove it. You go 8 times 1 is 8. 8 divided by 4 equals 2. It's easier. Uh, so for this one, blah, 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 blah. We're going to take the, no, you won't. I was going to give this assignment to you guys. But let's figure it out on our own right here. This is page 364. Just A, let's look at it right now. We're going to do it in class. What is the x value for the vertex A prime? Is it going by 2? 1, 2, 3, 4, 5. For this one, it's negative 2? Two and a half. 2.5, right? And then what about A? What is it? Negative 2 and what? And 5. That makes sense. All right, what about B prime? 2 and 1. And then what about B? 4 and 2. Now what about C? 2? 2 and negative 2, yes. And what about C, C, not prime C? 4 and negative 4. What about D? For D? Oh, D prime, yeah, sorry. Negative 2 and negative 2? And what is D? And negative 4, right? Now, what is the ratio? What happens? To go from, to go from the prime to this one, what are you dividing by? The what? Wait, it says what's dividing by right here. I don't know why they do that. It's stupid, because I just told you not to divide. Forget this. What are you multiplying by to get to the other one? By what? In fact, I'm going to change this for one reason, guys. Listen carefully. The prime, is that the image or the pre-image? The image, which is the final one, right? After the dilation. The one before that one should have been this one. So this one should have been here. And then this one should have been over there, right? Because you start with the ones that are not prime and you go into the prime ones. So to go from this one to this one, what do you have to do? By what? By half, right? You multiply. Do you just multiply one of the coordinates? What do you do? All two of them, right? Both of them. So you multiply by half, multiply by half, multiply by half, multiply by half, right? So x times half, x times half, x times half, x times half. And then for the y is the same thing, right? Y times half, y times half, y times half, y times half. Ignore that too. What I'm asking you, in case you're confused, is what do you have to do to these numbers right here to get to these numbers right here? Yes, because this book is stupid. Like you start with the image, the pre-image, and you go into the image, right? So that means you're shrinking, and this thing did it the other way. What? Times. I didn't want to put x because times sign because you'll probably confuse it with x. Okay, dilations, just to give you a heads up, it's not that much difficult than the other ones. See, enlargement, reduction, scale factor. I just talked about these things. And they actually use the same pictures that I used. What else? But anyway, just know this is like your eyes. When you use those dilation drops, they either get bigger or they get smaller, right? And they do it proportionally. You don't end up with a square eye. Well, what is it called? Not the eyeball, pupil. You don't. It still goes as a circle, right? And shrinks as a circle. So on your homework, it should cover everything we did for the transformations. And then tomorrow we're gonna finish dilation. If you have any questions on this, let me know. Yeah. Yeah.